Hey, I'm Sarah Hendricks, and I'm just a normal person who has gone through mold and wondering what to do in this journey. I've gotten connected with Eric, and we've made one video before. Eric is an indoor environmental advisor for Analytics Global, and he's worked in this field for over 30 years. He's a wealth of knowledge, and I've learned so much from him, and we'll be learning more from him in the future. But today is really special because we have his friend on. We have Greg Long here. Hi, Greg.
Hi, Sarah.
Um, I'm going to talk a little bit about you. So, just to get you introduced, you began your career in HVAC systems, so in California, we say HVAC, but you began your career with HVAC cleaning and restoration in this industry since 1973. So, it's a while. You've owned a large HVAC restoration company based in Texas, but you've worked all over the United different states, served on the board of directors for NADCA, which is the National Air Duct Cleaners Association, served on the NADCA Standards Committee for several years, currently serving on the board of directors for the IAQA, which is the Indoor Air Quality Association, and been trained and practiced in HVAC restoration, property restoration, and contents cleaning, which is a big deal for indoor environmental quality, and just held many industry certifications throughout your career, and currently holding a certification in the CIEC, which is Certified Indoor Environmental Consultant. So you have a lot of certifications and you've been in this industry for a long time. I'm really, really excited to learn from you because I'm pretty much coming at this with zero knowledge and hoping to make the right decision for my family as we select our next home to purchase, and even as a renter, just to know, yeah, what's a problem and what's not a problem.
Glad to be here, Sarah, and I appreciate the invitation. I hope I can help a little bit.
Yeah. Oh, you're going to help a lot. I'm
Greg
very
has
excited.
been one of my mentors. He's not only is he one of my best friends, he's taught me more about HVAC than anybody in this field. And as you can see, he's been around. He's been doing this since 1973. I think that's before you and I were both born, right?
Probably before a lot of people were born.
I'm just kidding. I'm just kidding. I like one thing about Greg. He picks on me a lot.
I
Last
do.
week, I was in a crawl space, and when I got to the very back, he found a vent where it allowed sound in, and he was back there playing rattlesnake noises on his phone to get my interest. So I got to pay him back a little bit today. Uh,
Oh, true friend. At least you're having fun with the job.
we do. We have a lot of fun, and this is a very important topic because in my field and what Greg does, when we look at homes, this is the biggest problem that you find is related to the HVAC system. The HVAC is the heart and lungs of a house. And so while there can be a lot of other problems, this is a recurring theme. And we thought we would give some information about how to deal with this. And so I asked the person who I think is probably the best in the world. If there's somebody better, I don't know who it is. I asked Greg to come out and give us some of his experience about how to deal with some of these problems. So I thought we would go through some of that.
Okay.
Thank you. And so I'll introduce the topics today because there's a number of things that we'll talk about, all related to the HVAC systems. We're talking about residential HVAC systems, which is heating, ventilation, and air conditioning. Under that, we'll talk about filtration, air conditioning, air handling units, HVAC cleaning, cleaning chemistries, which are the chemicals that are used, ducting and air duct cleaning, and get a little wrap up of what's recommended for air ducting.
Great. Well, I thought I would show, Greg and I gathered some pictures and some videos, and I thought I would share my screen and show a few pictures through PowerPoint and basically use that to talk about some of the things that are going on. So this is a typical system. This one happened to be in Florida, but this is a very typical split system where you have a component inside the house, and then you have a piece of equipment that sits outside called a condenser. And one of the common questions that I get, Greg, is do they communicate air? Does air go to the big fan that sits outside of your house? How does that work?
No. No, the only thing that communicates is the refrigerant.
So the refrigerant
And of course, some electronics through the thermostat and so forth.
Gotcha. So this is a common type in Florida, and there's different types. Anything that has a coil is going to collect water at some times. That could be in the north, it could be a humidifier that they've installed on furnaces. It could be a dehumidifier. It could be a lot of things that have coils. So one of the big problems is when you have coils, you have moisture, which is necessary for mold growth, and then you have the potential for a biofilm. And I think of a biofilm sort of, it's similar to dental plaque. It basically is a group of biological organisms that bond together, and they can glue themselves inside these air conditioning coils and in other places, and they can cause big problems for people in the house. So I wanted to go through and show a few situations and talk to Greg about how he would deal with some of these issues. So this is an HVAC system in Florida. Carrier unit, this is a 3.5 ton unit. Here's me pulling the filter out. I have a bad habit of pulling filters out without turning off the unit. I should have turned the unit off. The rule is these units have a disconnect, isn't it supposed to be within 6 feet of the unit, Greg?
Yes.
Yeah, so what do you think about that filter that I showed there, Greg?
That first of all, it's a good quality filter. It's a 4-inch pleat filter, which gives you a lot of surface space that helps you from losing so much pressure drop across the coil. And overall condition of that filter looks really good.
So it has a lot more surface area than the traditional 1-inch filter that most of us are used to, right?
It does. A lot of residential units use a 1-inch filter, and they can still use a 1-inch pleated filter, but the 4-inch gives you more surface area and less pressure drop across the filter.
What is the problem with having too much pressure drop on a filter?
It can cause your condenser to work too hard.
And if you don't change your filters enough, or you use a filter that's too dense, you could greatly restrict airflow, correct?
You can, and that's going to shorten the life of your compressor.
Won't that equate to more mold growth because the coils are going to get colder, not as much air movement, and you'll have more moisture and possibly more mold?
It is definitely a possibility that could happen. There's a lot of situations that could cause different things, but yeah, you don't really want to keep your pressure drop within compliance of what the manufacturer wants for that particular unit.
And where would you find that, in the manual?
Usually the manuals have it. You can usually get online and look up the serial number of the unit, and usually they'll tell you what their expected pressure drop across the filter would be.
Well, I've run across some maintenance professionals that have encouraged me to use what I'll call low efficiency filters, where you can basically see through the filter. They're dust filters. They say that they use those because they don't have any problems. Have you run into this issue before?
I have, and that's kind of old school thinking. More and more of the manufacturers are getting more in tune with indoor air quality, and are coming out with filtration systems that are better at filtering. The old 99-cent, you could read a newspaper through the filter. That's very old school. back in the day, we would say those things would stop ping pong balls and chicken feathers, and everything else went right on through. And that's pretty true. But it's being recognized more and more that good quality filtration is very important.
Gotcha. Well,
But I'll step in here. The other thing is you don't, residential systems are very easy to overfilter. And what I mean by overfilter is put a filter on there that will restrict the airflow too much. You don't want to do that, but you want to use the best quality filter that your system will handle, and or add more filter drills or areas to put filters to reduce that restriction.
good comments. Well, what are we looking at in this next picture here? What's this?
That you're looking at coils, that an evaporator coil in a residential style system that has frozen over. The most common reason that happens is if it runs low on Freon. It can happen for other reasons, like, restricted airflow and so forth. Most common is low Freon.
How do you know you have this problem?
Your house won't cool, and you won't be getting any air through your diffusers because that's a solid ice block.
Gotcha.
Is this something that a resident could open up and see themselves, or do you have to call someone?
No, they could open up and see it. If this happens, what you have to do is just turn the air conditioner off, turn the compressor off outside. In other words, turn it off at your thermostat and just run the fan. And it takes, it depends on how thick the ice is. It can take 2 or 3, 4 hours for it to thaw out.
Yeah.
But you do need to call an air conditioning technician, have him troubleshoot it, and check the Freon in your system.
What do you see in this picture, Greg?
Okay, this is fairly common to see. This is a filter box for a residential style system that's designed to take a 4-inch pleated filter, and somebody has installed a 1-inch pleated filter in it.
So you have
the problem with this is the filter doesn't fit properly, and it's going to allow a significant amount of filter bypass. And when you get filter bypass, you get particulate that passes by the filter and goes into the system. Air is going to follow the path of least resistance, and you're going to get some go through the filter, but because the pressure buildup, a lot of air with particulate in it is going to go around the filter and get into the system.
Right.
Then you just have all that debris flying all over your house and you're not really catching anything, right?
That's true. And it's collecting on your fan, it's collecting in your coils, making your coils dirty, and collecting in your ductwork system.
So the lesson here is don't skimp.
Exactly. Well, let's look at the next one. What do you see wrong with this picture? There's a filter here, obviously.
Yeah, that's another system that supposed to have a 4-inch pleated. Somebody shoved it 1 inch in there. And if you look up on that black sidewall there, that's internal liner inside the fan compartment. And you can tell by the dust patterns on there that you're getting a lot of filter bypass around that filter.
So the air doesn't know it's supposed to go through the filter?
No.
I see. So it wouldn't have that dust on there if it was going through the filter properly, or it wouldn't have as much?
If it's going through the filter and the filter is sealed properly, back up a little bit, Eric, back up to that one, back up to the next one. In any filter, in any system, has to be sealed properly. And one of the problems is a lot of the manufacturers don't make a means for the filters to be sealed properly. I've been in my house and I've been doing this for 15 years now, and it makes a huge difference. I've got sealing diffusers in my house. In other words, my filters are up behind a diffuser in the ceiling. And I'll put the new filter in, then I'll take some type of a tape, like a white masking tape or something, and I'll tape the filter to the return grill. So I've got a tight seal that forces all the air through the filter, and there's no way for the air to bypass the filter. And by doing that for 15 years or so, it's amazing how clean my returns stay, how clean my fan is, how clean my coils are, because I'm forcing the air through the filters.
Right.
Could you even do that here in this picture? Or no?
It wasn't done in this picture. There would be a way to do this in the picture, but
Okay.
this would have to be altered.
Yeah, okay. Would you recommend people do that in their homes if they're noticing a lot of air going bypassing?
Oh, absolutely. I recommend sealing the filters whenever possible.
Okay.
It's just the way some systems are designed, it's really hard to do.
Gotcha.
Good. Hey, Greg, I wanted to talk to you about, I've noticed two types of insulation on these air handling systems. This is a type that's fiberglass, and then I'm going to show one in a moment where the panel has a foil face. I'd love for you to think about what we should learn from that, and if you have any comments on
Okay.
on what to buy if somebody was going to purchase an HVAC system. Here's me opening up an air system. You want to cut the power to these units beforehand. And then this is the door I was talking about.
Oh, yeah.
That is a full face insulation, and what I like about that is that prevents dust particles, particulate, and moisture from entering the insulation. And it's easy to clean off, and you usually don't see mold growing on it because there, it does, the moisture is not penetrating and building up inside the porous fiberglass insulation.
Right. So get a foil faced if you have an option, right?
Correct.
And so what are we looking at here? What's the next thing I'm showing here? Let me see. Oops. Let's skip ahead a little bit. Let's watch me pull the. There we go. So we're looking inside. That's the coil section, correct?
Yes, that's your A-frame coil below your fan in the air handler.
I'm pointing out a little bit of mold that I noticed on the stickers. I don't know why they put the stickers in there, but they tend to grow mold on them.
They do.
So this is what, the blower wheel?
That's the blower wheel. And you've got a sticker on that blower wheel. It's got a little bit of mold.
There in the top, it looks like there's some mold on that sticker.
Yep.
Okay.
Now, right there, a proper duct cleaning would, a company that does it correctly would pull that blower out, take the motor out of the blower, and wet wash the squirrel cage and the blower housing, and then put it back together.
So they would pull this whole blower out.
Yes.
So that's the section they would pull out right there.
Yep, they pull that blower completely out, take it outside, take the fan out of the blower, wash the squirrel cage wheel and the blower housing, then clean off the wires and everything and put it back together.
So there's a nut here. This all disassembles.
That's your set nut. Yep.
Yeah.
And they should know how to do that. There's actually a tool made to pull that shaft out of the fan wheel.
So I don't know if you can see these coils very well, Greg, but would you say, I mean, these blowers, would you say the blower fins look pretty clean on this?
They're not too bad. They're starting to collect a little bit of dust and dirt. I obviously have seen much worse, but they don't look new.
Yeah, this system coincidentally or incidentally was a 12-year-old system.
Oh, wow.
So this is pretty old.
Now, one of the things they need to pay attention to is if you look at those fan blades, they're concave shaped. And it's designed to, each one of those blades picks up a certain amount of air and moves it through the system. As they get dirty, that concave fills in. And then the fan is not moving the correct amount of air that it should, because you're smoothing out that concave shape.
I think I have a picture of that right here.
That's, yeah, right here is a good one. I've seen them worse than this, but this one's pretty bad.
So
There's no
that's
way
mold
this,
from my experience right there.
yeah, there's no way this fan can properly be cleaned unless it's removed from the unit and disassembled and power washed.
Gotcha.
Is that good enough, or do they need to replace it?
No, that's usually good enough. You should be able to get bare metal underneath those fan blades.
Okay. Should you remove all the stickers if you can?
I always did.
You know, how about this? What would you do with that? This is the panel off the front of an air handler, and you can see there's mold growth down at the bottom. What would you do with that?
You would try to HEPA vacuum that mold growth off first. And you would determine if the mold growth was just surface or if the mold was actually growing into the matrix of the insulation. So if it was just surface mold, you can clean it off and you try to correct the problem that's allowing the moisture to get to this insulation. Otherwise, you can remove that insulation and install new insulation. You can go back with the exact same kind of fiberglass insulation, or you can put a closed cell insulation on it to replace it. My preference is to replace it with a closed cell insulation.
Is that like a product I've seen called INCOA?
Exactly.
You spell that what? IMCOA?
That's correct.
Yeah, that's a great product.
So
And
for
so
me,
go ahead, Sarah.
I'm just curious. So is this the door? I'm trying to visualize. I've actually never like pulled apart an HVAC unit. So I'm trying to understand where this piece would go. Is this the door, the panel that comes off to look at it?
Right.
Yeah, this would be one of the access panels to the air handler.
Gotcha. Which is similar to that door that you showed before that you said you liked the foil, but you like the foil
Yes.
with
This is very similar, except this does not have the full facing on it.
And so we're looking at the inside section of this. This would face
Sure.
inside. So I've just pulled it out so that you could see what it looks like. But
And do you see mold growth like this on the foil faced ones?
not
Not
really.
usually, no.
Oh, well, that's great.
So that's a reason to get the foil face. That's for
Okay. Sold.
sure. Okay, so here's a HEPA vacuum. And what I'm going to do is vacuum off visible mold before I touch it. That's just my way of doing it. I like to get the loose spores off of the surfaces. And notice I'm using this vacuum. It's called a HEPA, HEPA, which stands for high efficiency particulate air filtration. It's basically a filter that hooks on as a supplement to a traditional vacuum cleaner. And what it does is it captures the really fine particulate down 99.97% of particles down to 0.3 microns in size. So it's all the little stuff, including the mold spores. So
Yeah, if you don't use a HEPA vacuum, Eric, all you're doing is transferring the mold spores in here to the environment where the HEPA vacuum is sitting, or where the vacuum's sitting. So any cleaning inside of these moldy areas needs to be done with a HEPA vacuum.
correct. Okay. So let's look at another video here. So we're looking at a product here. This is the probiotic cleaner that I used. I know that you are a rep for this and were part of the developmental team. What made you want to go to this cleaner, Greg?
Eric, I've been cleaning coils for a long, long time, and I started studying coil cleaning in depth because I was doing a lot of commercial coils for large high-rise buildings and mechanical contractors and stuff. And I started studying it in depth in the early 90s.
Yes.
And it didn't take long to figure out we were able to get the coils clean, but with the building automated systems, you could tell that their performance was starting to fall off in a few weeks. And we knew it wasn't because they weren't clean, they were clean. So we started studying it, and we actually cut coils apart and looked at them, and the culprit was biofilm growing inside the coils. So I tried every type of chemistry known to man to get rid of biofilm, and nothing worked. I mean, I tried everything and nothing would work.
Did you ever try steam cleaning?
Yes, steam cleaning would clean the coils extremely well, but it wouldn't get rid of the biofilm. Now, you're going to knock the biofilm down, but the biofilm develops itself in a manner to protect itself. So you can reduce it, but you're not going to get rid of it. So it was very frustrating. So probably, gosh, I don't know now, 12 years ago or so, a colleague at the time called me and he said, I found out about a company that's being extremely successful in making products to get rid of biofilm in the poultry and agricultural industry. Let's call them up and talk to them. So we called them up and talked to them, and fortunately, one of the partners was a mechanical engineer, and he understood immediately what we were running into and what the situation was. So they agreed to look into it, and they called us back and they said, yeah, we think we can make a coil cleaner that will clean the biofilm out of coils. So they did. And we selectively put it in the hands of 4 or 5 contractors, high-end contractors across the country to field test for a long time. And the results started coming in, and it was unbelievable. Then we got it in the hands of more contractors, then more contractors. And the results people are seeing from using this probiotic coil cleaner and improving the performance of coils is quite significant. So that's kind of how we got into it. It is a pH neutral coil cleaner.
Why is that important?
That's important. Most of the coil cleaners out there now are a high pH coil cleaner. And the pH scale runs from 7 is neutral and 14 is very caustic, and 1 is very acidic. Most of the coil cleaners that are being made are caustic, which puts them up in a high pH area. Probably one of the most common ones out there is a pH 14. So I think you're involved with this, and this with me, Eric, maybe. We had a client using a pH 14 coil cleaner, and we read on the bottle, and the bottle said diluted 4-1. Or I don't remember, it's 4 or 5-1. And we diluted it exactly that amount. And then we tested the pH in it. And after it was diluted, it reduced the pH by 0.5 point.
Right.
Which means it was still caustic. And what happens when you put something caustic on aluminum fins that these coils are made out of? A lot of guys like to use it because it makes the coils look real shiny.
Right.
Well, the reason it makes it shiny is stripping metal away. And if you look at one of those aluminum fins under a microscope, now after you use that caustic coil cleaner, it's got pits and valleys in it. And those pits and valleys prevent the coil from draining as well as it's supposed to drain, which means it holds moisture, which means it collects dirt quicker, which means it grows biofilm quicker.
You know what I think of is a climbing wall at the gym. You know, you have all these little handholds.
Yeah.
Basically, when I see these coils that have been treated with a high pH coil cleaner, and they're all pitted, they look clean, but it just makes the biofilm glue itself easier to the surface.
It absolutely does. And another problem we find, particularly on commercial coils, not so much on residential coils, because residential coils are relatively thin, but you get in the commercial application, you get really thick coils. And I've actually seen where guys have used the high pH coil cleaner for years on their coils. And it's not getting rid of the biofilm. The biofilm's staying in it. And if you're familiar with these chemicals, if you've ever used them, they're very, very, very hard to rinse out and get 100% rinsed out. So they're not being rinsed properly, which means this high pH coil cleaner is being held inside the coils. And I've actually seen coils where the internal parts of the coil has turned to a mass of metal and they can't even pass air.
Wow.
So it can be very damaging.
Well, what happens to your skin if you pour with a high pH coil cleaner?
It's going to burn you really, really bad.
What about your product? What's the pH of this?
It's a neutral. I've actually in demonstrations poured this all over my hand, and you can't feel it at all.
So it's basically
I've got some right here. I've got some right here in Little Deal that I use for different things around here, and I'm going to spray it right there on my face. And I'm going to sit here, and you're not going to see me flinch a bit.
I hope so. You gonna brush your teeth with that?
You could. Oh, I'm not going to say you could, but
so I love this cleaner, by the way. So explain what how the coils work. There are lots of little rows of metal, right? That where the air exchange happens.
yes, your heat exchange happens through the fins on a coil. You've got your tubes that carry your refrigerant, and then your heat exchange takes place with the fins on the coil.
And how thick are these coils typically?
Usually residential are what we call a 2-row, or maybe a 4-row coil, which means they've got 2 or 4 rows of tubes going through them. You know, we've got commercial coils, obviously, that are much, much thicker.
But so you have this thickness. You sent me an article years ago, and it made a dramatic impact on me, where they cleaned a coil, and in this article, and they showed pictures of it, and it looks so spotlessly clean. And then they disassembled the coil, and they laid the fins out, and what you could see is that on either side of the face of that, the coil was clean in that spot, but in the middle there was a stripe of this black moldy biofilm down the middle.
That's correct.
So
that's correct.
If you laid all those fins out, how much surface area would you cover? Would you maybe like a
Oh, I don't know, Eric. It would depend upon the size.
It'd be pretty big though, wouldn't it?
Yeah, it would. It depend on the size of the coil. But to add one thing to this, I was asked to inspect some coils at a well-known facility in California here a few years ago, and they had a dirty sock syndrome problem in the building, and they had tried everything, all kinds of cleaners, high-end UV lights, and everything. And they sent us a coupon of those coils. In other words, they had a coil they were taking out, so they took I think it was like a 3-foot by 3-foot section and shipped it to us. And you and I sat down in somebody's shop and pulled it apart fin by fin. These were copper coils. They were copper tubes and copper fins. But because somebody had been using very caustic coil cleaners in them for years, there were holes eaten in the fins. Even the copper fins had holes eaten in them when we peeled them apart.
All right.
Remember that?
I do. It's short chain fatty acids. It eats those coils up. The bacteria will form acids that eat this stuff and cause some tremendous odors. Dirty. I didn't really ever want to be the world's experts on dirty sock syndrome. That wasn't my thing that I wanted to do in life. but you know a lot about it. I know that. So the thing that was remarkable to me is that these fins, they look flat, but they're really not. They're embossed.
No, they're what we call embossed. Yeah. They're not flat. They're embossed, and different companies use different patterns, but most of them are kind of, well, I don't know, like a Z-shaped embossed or whatever. They're not flat.
Well, the thing that made it that I thought was important about that is that you can't just pass things through the fins. Because they're embossed, it's a tortuous path to get through there. Makes a tortuous path for the air, more contact time. And so it makes it a lot more difficult to clean these coils. And that's where I
It
think
does.
this product has the real advantage over everything else that I've worked with.
It does. And on a coil cleaning procedure, and all the contractors that buy this product for me and use it for their coil cleaning, I get their technicians on a Zoom meeting, and I go through the proper coil cleaning procedure on how to do it. It's very important to know the proper coil cleaning procedure, more so for commercial than residential, because commercial coils are so much larger.
Well, let me show, is there any special handling that you have to do with this particular cleaner?
Yeah, there is, because it has live active probiotics in it. There's three main rules. We don't want it left anywhere like in a truck or something that's going to get above 130 degrees, because we don't want it to get above 130 degrees. It'll kill the probiotics in it. And we don't want it to freeze. And the other rule is before you mix it up in water, we want you to shake the jug just like you shook it right there, because we want you to mix those probiotics up in the jug. And there's a fourth rule. After it's mixed in water, its shelf life is 5 days. So after you mix it in water, if you don't use it all and you're not going to use the rest in your sprayer in 5 days, throw it out. It's got a 5-day shelf life after it's mixed. In concentrate form, it's got a 2-year shelf life.
Okay. Well, you're going to see me mix. I didn't have my glasses on. I couldn't read the thing on it, but the label says 10 to 1, right?
That's correct.
So 10 parts water to 1 part of this. Does this product need to be hot, or will it perform better when it's warmed, or does it really matter?
It doesn't really matter. You don't want it real hot. Usually when I first mix it up, I mix it up in lukewarm water. It doesn't have to be, but you just don't want the water to be around, 130 degrees or more.
Well, one thing that you taught me is that you've got to use a clean sprayer, right?
Yes,
I went
you
and
don't
bought
want
a
to use it.
sprayer special for this.
Yeah, you want to use a clean sprayer. You don't want a sprayer that's had anything else in it that might attack the probiotics.
So probiotics are basically good bacteria that outcompete.
They are, and basically the way this product works, biofilm is constantly eating and eating and eating and growing. And what this product does is it consumes the nutrient source, so that the bacteria in the biofilm don't have anything to eat. One of the things we learned through chemistry over the years is, I think we're on our 6th or 7th generation of quaternary ammoniums, because microorganisms mutate. They get, they mutate to protect themselves from chemistry. They cannot mutate from starvation, and we're starving them to death. Plus, the probiotics create their own biosurfactant, and they create their own natural enzyme, and they have a tendency to create the enzyme dependent upon what they're trying to work on. So we're fighting nature with nature.
So here I'm using the probiotic on a cloth, on a microfiber cloth. I'm going to use that to wipe down the mold growth that I saw earlier in the air handling system. And so here's some mold that was on that sticker, and it wiped off quite easily. You can see I picked up quite a bit. So here I'm wiping the inside of the cabinet for that. This is something that people do it quite a bit. A lot of HVAC contractors recommend what I'm doing right here. Take some bleach, pour it down the condensate drain to try to clean out the sludge. Now that drain goes to the outside. It drains the water from the coils to the outside of the house.
Right.
And one of the things that I see in people's houses as a big problem is a lot of times that drain will plug up with sludge, biofilm of its own.
Right.
And if it
And
overflows, it goes everywhere.
bleach is very good at cleaning that drain out. However, there's a caveat to that. If you're going to do that, let that bleach work for maybe up to an hour, and then go flush that with clear water and flush that bleach out of the system. What we don't want to, bleach is sodium hypochlorite, and it's very, very corrosive. And what we don't want is those corrosive gases backing up into the air handler. And stop it right there. If you see those tubes, those round tubes at the end, that's a galvanized coil frame that those tubes are going through. And you see the rust on there?
Yeah, I knew what you were saying.
That rust can be caused by a lot of things, but bleach definitely is not going to help that, and might even be part of the cause of that if that's been done in that air handler a lot.
So the vapors could come up these pipes and get in here and cause the rust.
Yes. Now, if you clean your coils with a probiotic coil cleaner, the probiotics rinsing down and going through your drain system will keep that clean.
Can you use your product to pour down the condensate drain?
Yeah, it just takes a little longer to work. What I like to do is clean my coils with a probiotic coil cleaner, and then go outside where the drain line drains outside and suck the debris in the drain line outside through the hose, through the drain system to the outside with a vacuum cleaner.
Yeah, that would solve a lot of mold problems.
Yeah. And or you can use compressed air, but most homeowners don't have compressed air to do it with.
Gotcha.
Is this something that the homeowners should be doing themselves as maintenance, or would you have a company come in and do all this?
Well, yeah, you can do that yourself. A lot of homeowners can and some can't. It depends on where the air handler is located, what their mechanical ability is. But most homeowners usually hire somebody to do it.
Gotcha. And with that probiotic, so are you saying that that could actually be poured down that coiled tube, or that, what did you, I forget what you called it, but it could be poured down the tube, the drain pipe, in lieu of the bleach, but it would take what, hours instead?
Well, it depends on how bad it is in there, Sarah. You know, if there's a big buildup, it might take a little bit longer to work through it than bleach would, but it wouldn't be corrosive like bleach.
I see. So long term, it's better.
Yeah.
And is that product something that homeowners would buy, or would the mechanic already have something like that, or could you request that they purchase that?
You could request that they purchase it, or the homeowner could buy it too.
Okay.
Yeah, I'll put your at the end of this PowerPoint, I'll put your email. I'm assuming it'd be okay if they emailed you if they wanted some more info about this.
Sure, absolutely.
Um,
Okay, now you want to talk about this photograph?
well, I'm just doing a wipe down. There was a little bit of mold on some of the plastic. And when we went over this earlier, you had mentioned to me that one of the things that you like to do is pull these screws out, right?
Well, if the coil hasn't been cleaned for a long time,
Mm-hmm.
I highly recommend that you have a contractor take the coil out.
Yeah.
And if you go back to that photograph,
Oops,
okay, that top plate up there, when you remove that top plate, that plate right there, that kind of V-shaped
this thing right here.
galvanized plate,
Yeah.
that sits directly on top of both sides of the coil. And underneath that plate is all kinds of gooey biofilm and stuff. So if the coil hasn't been cleaned for a long time, the only way to actually get that thoroughly clean is pull it out, take it apart, clean it, and put it back together. Now, once that's done and you've got the coil really good and clean, cleaning the coil once a year with the Probiotic and spraying the coil 2 or 3 times a year with just the Probiotic would go a long ways in keeping that coil from getting nasty like that up there again.
Let me ask you this question, because I'm sure most of us have seen ads in our local newspaper where they have people that will come out and clean your system for say $96 or something cheap, $99. What are you getting when you do? Are they going to pull this plate off when they clean your system?
They are not. You're not getting anything for $96.
That's what I
Well,
thought.
think about it. It's mathematics. Most of these technicians are getting paid probably an average of $30 an hour.
Right.
They're going to drive a half hour to 45 minutes to an hour to get to your place. And it's going to take that long to get back. And then that leaves them an hour to do anything. The average proper coil cleaning in a residence, a 1-unit residence, is around four and a half hours, maybe 5.5 hours.
Wow.
So and that's 2 people working. So that's the average amount of time it takes to properly do a residential with 2 people.
So what's the catch?
They're getting in the door. It's a scam deal. They're getting in the door with a cheap, eye-catching ad, and they're hitting the internet real hard with these now. And most places they've actually upped it now. Instead of $95, they're saying $119. Okay. But once they get in the door, then they're going to try to sell you all kinds of things like UV lights, fogging your system for mold, and all those things all of a sudden become very, very expensive, and you're going to end up spending a whole lot of money for nothing, and it's going to be a total waste of money because the people aren't qualified and they don't really know what they're doing.
Well, let me ask you about that, because you mentioned fogging. I hear this probably every day. Somebody wants to come out and open up the air system and then put a fog of some disinfectant in the system. Does that work? Is that legal?
No.
What's your opinions of that?
First of all, it doesn't work. If they're saying they're disinfecting your system, if you look at most of these chemistries out there that are disinfectants and or sanitizers, that product has to stay wet on the surface for 10 minutes. That's a lot of product.
Yeah.
And they're not putting that much product in. And second of all, if you have any porous internal components like we've seen in these photographs of the internal insulation and stuff like that, it's not legal. EPA, and to go one beyond that, the EPA has never registered and never will register anything for sanitizing or disinfecting ductwork. And I'll tell you why, because we've had the conversation with them. nobody's been able to demonstrate how you can get every square inch of every component in every duct system wet and keep it wet for 10 minutes to get the proper amount of contact time and dwell time to disinfect something. So they're just not going to do it. Now, there are products out there that are registered for any hard surfaces in the duct system. Like if you can get to the fan housing and wipe it and put in disinfectant, but quite frankly, that's not necessary. All you got to do is get it clean. Hard surfaces can be clean. There's no sense in putting a lot of harsh chemicals in the ducts in any of these systems if they can be cleaned down to bare metal.
And
So-
as you said before too, wouldn't the probiotic be better than any chemical you've tried? So would it not essentially do the job well?
The probiotic is a coil cleaner is really a very, very good cleaner. I use it for cleaning a lot of things around the house, and I've used it for cleaning a lot of components inside the HVAC systems. And you know, if you miss anything, it actually migrates, and as long as there's a nutrient source, it's going to stay active.
That's
All right.
great.
Let's move forward. I was actually showing here, spraying the coil with my mixture from my pump up sprayer. So I'm rinsing this with the probiotic.
Nice. And do you just leave it there? Do you have to wash it off?
Pardon?
Do you leave the probiotic there or do you have to wash it off?
Yes and yes.
Okay.
For the initial clean, because the probiotic coil cleaner cleans differently than the common coil cleaner. If you've got a lot of biofilm in the coil, we'd like to see it have some dwell time because we're using biology to break down biology or clean biology. So a lot of my guys that clean large commercial coils, they'll go in 3 or 4 days in advance and spray a coil down. Then they'll come back 3 or 4 days or 5 days later and wash the coil. And everyone tells us that by doing that, coil cleans a lot easier and a lot better because the probiotics have had time to work. So on residential, you don't have to leave dwell time, but if you can, that's fine. And then rinse it, but you only need to do that about once a year, but it doesn't hurt to come back 2 or 3 times during the year and just spray some coil cleaner on the coil and leave it.
Okay. That's great.
Let's talk a little bit about ducting. This is some of the common problems I see. Do you see that mold growth that I'm seeing at the joint duct? I see this a lot of times right where the air handler meets the supply duct, where the air leaves the air handling system. I also see it up in attics where it's hot and there's ducts connections. There's mold that tends to grow where the connections are. What do you commonly, what causes that problem and what would you do about that?
All right, there's 2 things that generally cause that. One is there is an air leak there, or the most common problem is that there is a breach on the thermal insulation at that point inside the unit. In other words, where those 2 components are connected together, there's a breach in the insulation that's allowing condensation to build up on the outside of this cabinet. Probably, if that's the case, the way I've seen most people fix it is they will clean that off, then they'll wrap that area on the outside with a 4-6 inch wide piece of insulation and tape and masking it down. That creates that thermal barrier there that you need to keep that condensation from developing.
Good. Well, let's go to the inside of the duct. Now, let's talk about ducts. A lot of people don't understand how these ducts work. There's 2 different sets of ducts, right? There's the return duct, then the air goes through the air conditioning system or the air handling unit, and then goes into the supply ducting. Is that right?
That's correct.
And so where do you typically find mold growing in these systems? Where's the problems?
Supply side, and usually closer to the air handler. There's more moisture coming off the air handler. And or you see them in supply boots in the ceilings that have usually an insulation problem, or there's a humidity problem in the house.
Well, a lot of people get worked up because of the return side. I've noticed the return side gets really dusty,
It does.
but it doesn't really get that moldy. Would you agree with me?
That's true. The moisture is usually not there to create a mold problem.
I got you. And so the most logical place, if a person wanted to find mold, would be in a place like this, where this one's on the outside of the unit in the garage. But if there was going to be mold, it'd be likely on the inside of this duct in the first foot or so of insulation on this ductboard supply duct. Is that what you've noticed?
Yeah, that's true. And one of the functions of the air conditioning coils is, that they take heat out of the air, but they also take moisture out of the air. And that's the reason you have the drain pan. That's the reason they drip water outside your house, is they're stripping moisture out of the air. And if the fan is running too fast and or the fan runs after the condenser shuts off, it'll blow moisture up into the supply plane, and it'll create moist situation up there, which is ideal for allowing mold growth.
Well, I want to talk to you about this. So this right here, we call fiberglass ductboard, correct?
That's correct.
It looks like foil faced on most of it, but on the inside, it's a dense fiberglass board. So and would you say most of what's out there in the residential world is going to be that material?
Yes, right now that's kind of the way the residential industry has gone.
So they use this, and then at a certain point, they'll branch off and kind of have octopus off with all of these flex ducts. Is that right?
That's correct.
So let's talk about this type. I think I have a video of this duct. I opened it up just past the coils. This is what it looked like inside. Do you see any problems here?
No, this one looks really good.
So this is what it's supposed to look like. This is a clean duct. One of the things that I found interesting about this duct is that this duct is 12 years old, which is about the end of the lifespan for this type of material. And yet we never had, the homeowner never had things like UV lights and all kinds of other hydroxyl generators and things in the system. And to me, it's pretty remarkable that that's the case.
Yeah. Well, yeah, this plant here is really technically not close to the end of its life cycle because it's still in good shape.
Gotcha. Well, let's talk about.
I'm just curious, does this person live in an area that's dry? Is there a reason why that may happen?
You know what? This was taken this week in Florida, which is probably the moldiest environment you can imagine.
Okay.
And so I think my takeaway from this is the benefit of having good filtration that fits well. This is a 4-inch pleat that we saw earlier, and it fits well, and the filters have been changed. And so I think that's the benefit of just keeping the nutrients out. Mold really, there's nothing really to eat on fiberglass. Most of the things in air conditioning systems aren't mold food. I mean, you got plastic, you got metal, and you have this fiberglass. What fuels the mold growth is the moisture. and also the dust particles that get by the filters, and that becomes the nutrients or food source that the mold needs to grow. So
I agree.
it's really important. Let's look at, I want to show you another one, Greg. What do you see in, what is this type of duct that you got here? What are we looking at?
All right, that is metal ductwork insulated on the outside. Okay, and as you can see, it's dirty, but you can see that it was rubbed on right there. Metal ductwork, even if it's dirty, can be cleaned down to brand new condition.
So
And
this stuff is very cleanable.
oh, extremely cleanable, long lifespan, very cleanable. It can be totally clean and costs more money, but it'll last longer and create a lot less problems.
Yeah. Okay.
Unfortunately, due to the price of metal nowadays, it does cost more than it used to. However, it is the best option.
Well, you know, metal this is galvanized metal, and one of the things about galvanized metal is it has zinc in it. Zinc has a lot of antimicrobial properties, so it's a superior product all the way around.
It is.
Well, let me show you other scenarios. This is some insulation that I took a picture of inside of a duct board, and you can see it's not very dense. One of the things that I noticed on this are these spots. These are probably the size of a dime or a little bigger, quarter. And so this is mold growth growing on these surfaces. And this is what is undesirable in these houses.
Okay, this photograph is showing a duct system that has fiberglass internal duct liner in it. And the system obviously has had high levels of moisture blowing through it, and it's collected a lot of dirt, debris, and microbial growth. So it's going to take somebody really qualified to be able to understand how to clean and handle this type of system correctly.
So let me get this straight. This is a metal duct on the outside, but internally insulated. Do I have that right?
That's correct.
And so the ideal situation would be not to have this insulation on the inside, but to wrap it on the outside of the duct.
Yeah, they do it this way for a few reasons, and one of the main reasons is it's probably less expensive to manufacture it and do it this way, but the main reason is they use the internal insulation as a sound attenuator. Because the air moving through the ductwork with internal insulation is quieter than air moving through bare metal ductwork.
Gotcha. Well, here's another scenario that you'll probably recognize. Do you see what I see in this duct?
Yeah, it looks like paint over spray blowing into the duct system.
Yeah, this was a brand new residential system, and so it looks like they didn't use care when they did the painting. They didn't have the ducts sealed up. And the reason I put this in the presentation was to really show this next photo. This is a flex duct that connects to that other duct, and it's a lot easier to see on the flex duct where there's dust that's accumulated. This is a brand new system, and yet there's lots of dust, I'm sorry, in the duct. So
that's evidence that they ran the system while they were in the finish out phases of construction, and the system got dirty from construction dust and debris.
So like this system was in South Carolina. It's probably pretty common in a hot area, which is that way most of the year, where they'll run that to try to cool themselves off. But is that appropriate?
They need to use really good filtration if they're going to do that, to try to prevent and lessen this impact, and or use supplemental cooling instead of the equipment intended to be used in the building.
Right. Well,
Now I hear from my friends all the time. I bought a brand new house. There's nothing wrong with it. There could be no issues. So this is one of those reasons where would you want to have an inspector come look at the ducting before you move in? I mean, obviously an inspector should, but it's possible to have an issue before you move in, perhaps, or at least extra dust in there.
Absolutely.
Okay.
well, Greg, if that brings up a good point. If you were going to build a new house, what would you be looking for um, if you were going to buy a moderately priced HVAC system? What types of features would you be looking for?
Well, first of all, you need to make sure the system was sized properly for the home. That whoever designed it and put it in ran their manual J, manual D, and manual S properly and picked the the proper size of system, the proper duct layout, and things like that. You want it designed properly for that house and sized properly for that house. Next, you want to look at the quality of the workmanship. How well was everything put together? Is it a nice, neat, professional, clean job, or does it look kind of sloppy? Like, I see a lot of things on these jobs that say, "Oh, that was done 5 o'clock on Friday," but you just that's the main things you need to look at.
What about materials? Would you recommend the flex duct if you're planning to live there for a long period of time, or what's your thoughts on ducting?
Well, I don't have a problem with flex duct because they have improved it now where it's much better than it used to be. And if it does get dirty, a good quality contractor can properly clean the modern flex duct and get it clean if they know what they're doing. And most of your good quality contractors do. Second of all, if you do need to replace it, it's very inexpensive to replace it and easy to do. So I don't have a problem with flex duct. A lot of the systems where you have flex duct, like we talked about before, have ductboard plenums that the duct hooks into. If the system is sized properly, has good filtration in it, and is maintained, that's usually not a problem. If it does become a problem, there's things we can do to those plenums to fix that problem and or replace the plenum, and it's not as expensive as a metal plenum. So, in a residential situation, I don't have a problem with a lot. In my house, I've got flex duct and I've got ductboard plenums, and I'm okay with it because I know how to deal with it if I develop a problem. But also knowing how to maintain and take care of my system, I don't develop problems.
Would you recommend a 4-inch pleated filter over the 1-inch?
If you got a situation where you can put it in, yes. Now, the way I have it set up in my house is I've got 2 return grills in my ceilings in different locations in my ceilings. And those return grills only take 1-inch filters. But by having 2 of them, I've got a lot more surface area than I really need, and which kind of serves the same purpose as having a 4-inch filter.
Well, let me ask you about this. This is not a lightsaber from a galaxy far, far away. This is a UV light system, one of many different types that people have installed near the coils to try to prevent air quality problems. There's a lot of sales pitches. What's your thoughts on these?
My thoughts aren't very popular, because I'm not a big fan of them because they're oversold to do more things than what they actually are capable of doing. However, there's more and more research coming out from universities doing studies on these, and the most recent was by MIT, that these are creating more smaller particles and things in the air that are more dangerous than what they're trying to get rid of. And these are good. They'll help maintain a system in direct contact with that light, but they're not going to maintain the inner parts of that coil, because light waves do not bend. And there's areas in that coil where those light waves just can't get to.
Yeah, and the mold spores that pass by that light are going so fast, it's not like they're getting killed either, are they?
No, it's all dependent upon dose and exposure, and each mold spore requires a different amount of exposure time, and that exposure time changes with the distance from the light it is and the speed it's traveling. So to think that this is taking care of particulate mold spores or bacteria or whatever flying through the air, particularly mold spores, it's not doing it. It's helping keeping the area right around the light clean, but it's not really doing anything for the air flowing past it.
Well, let me ask you this also. What if I'm a homeowner that wants to get a quality contractor, how would I go about finding a contractor that understands HVAC hygiene? What do you recommend that
I would recommend going to NADCA.com. That's NADCA.com.
I put that
That's
on.
that's the National Air Duct Cleaners Association.
Mhm.
And if you go to their front page, they've got a pop-down menu for homeowners. And they've got several videos in there. They've got reasons for cleaning. They've got videos on what to expect to get a unit clean and things like that. They've got a lot of information there. Then you go over to another tab, it says facility managers and then industrial professionals. You scroll down through there and they've got white papers that are good to read. So they've got white papers on chemicals to be used in duct systems and white papers on a white paper on UV. I think they may be going to change that after some of the recent studies. I don't know, but NADCA has got a lot of information, and I would look for a NADCA certified contractor. And if you can get the person that's actually got the certification on the job doing the work, that it's that much better.
And so I've been on the site before. They have a pull down where you can actually search by your zip code, correct?
It's called Find a Professional, and you can go in there and find people close to your area.
Well, those were all the questions I had. Can you think of anything else we should ask Greg while we have him on the line, Sarah?
I guess I have a question about mycotoxins and air ducts. Do the filters typically, are they down to HEPA level for all the air intakes? And if you have a mycotoxin issue in your house, do you just need to replace all of your ducting and start over?
Well, no, the filters in your air conditioner are not HEPA level.
Okay.
Usually in residential, I mean, you might find residential systems can't handle the pressure drop that a HEPA would create. I don't know. I'd have to defer some of that to Eric. A good thorough cleaning would probably take care of a mycotoxin. And if a cleaner knows going in that they need to address the mycotoxin, they can adjust their cleaning procedure to try to do that.
Okay.
Yeah, I agree with you. Most mycotoxins problems people don't understand they are dust problems. So it's really a dust battle. You're never going to get every speck of dust out of a house that's had mycotoxins. So if you can get the majority of the dust out, you're a lot better. So that would be a good topic for another day.
Yeah, that sounds like it.
Hey, Greg, if folks wanted to contact you, are they free to send you an email at this email that we have here?
Yes, absolutely.
Well, we both we really appreciate your time. You want to wrap us up, Sarah?
Yeah, so there's just been so much great information. We talked about filtration and air handling units and cleaning and chemistries, duct cleaning for all the air ducts. And I feel like the big takeaways for me were make sure to get a professional NADCA certified professional in there. Do regular maintenance on it. I don't know what time frame that you would suggest, but we can always talk about that in the future. But just having regular maintenance, it seems like having the correct filters, making sure there's no air going around the filters is going to hugely increase the lifespan of your ductwork and ducting.
Yes.
Yeah. And then also just the foil face of the doors and taking stickers off if they're moldy, if you can. It seems like a big issue. And no fogging, and UV lights don't work. I feel like all of those are really, really helpful things for us to know so that we don't get scammed or pushed in a direction we don't want to go that won't really address the root problem.
Yeah, and UV lights work to a certain extent, but I've never seen where they deliver what they're sometimes promised to do.
Right.
And, when I had my restoration company, I used UV lights for disinfecting certain things, but to have them in a live active airstream and expect all these results, they're not going to provide. I've never seen evidence that they provide that. And in some of the newer studies that are coming out, I'm beginning to question if it's even a good idea, and if they need to be cleaned frequently. If they're not, they create ozone. So there's a lot of problems there that people need to be aware of.
That's so great. It seems like it's so, so important to have a professional that actually knows what they're talking about in there, and that the job is going to take a lot longer than an hour. So now we know what to expect as homeowners and where to find a good professional near us. So thank you, Greg, and thank you, Eric.
Well, one last thing,
Yeah.
people need to keep in mind: to get a proper system cleaning, it's not going to be cheap. It's going to run between $500 and $1,000 for a 1-unit house. There's factors that determine the price, and you get what you pay for. If somebody's trying to sell something real cheap, it's usually really a total waste of money.
That's great to keep in mind. Amazing. Well, thank you both. I really appreciate you both coming on and sharing. And all this information we'll have available for people who need to click on and find NADCA or get a hold of you, Greg. And what area are you in again? You're in Texas still, right?
Yes, I'm in Texas.
Okay, great. Well, wonderful. It was great talking with both of you today. Thank you.
I enjoyed it. Thank you for the invite.
Of course.
Thank you all.
Bye.